Next, we will learn about the determinant of a 2 by 2 matrix. A 2 by 2 matrix, this is how a 2 by 2 matrix is written. And this is the augmented form of the matrix. Okay, so this is how you write the augmented form of the matrix. So it's basically moving A, B, C, D over here. Don't forget the curve brackets at the end. Okay, and then this line over here is like as if it represents X and Y. Okay, and EF is moved over here. So this is the augmented form of a matrix. So for example, if we want to find the value of X and Y, we can perform the elementary row operations to reduce it to in this form. So you don't have to memorize this form. This is the theory. There is a practical method to actually do elementary row operation, which is you need to get a corner, left hand corner of a 0 for your, you have to convert the C here to 0. So there is some steps involved. And once you get that, you can solve your X and Y accordingly. So for example, the solution will only exist if your determinant is not a 0. So this is a very important property here. The solution will only exist if your AD minus BC does not equal to 0. So for example, AD minus BC is the determinant of the matrix. The determinant, you can actually use a notation of DETA or modulus A. This simply refers to determinant. It can be a 2 by 2, or next I will introduce to you a 3 by 3 matrix determinant. So that's how you actually denote the determinant. So for example, if you have matrix A, B, C, D, determinant of A, modulus A, all refers to determinant. This is how you actually identify determinant A, B, C, D. This is exactly same like how I introduced the cross product formula for vectors. Yeah, so AD minus BC is actually known as the determinant. So determinant of a 3 by 3 matrix is identified using the cross product formula similar to vectors. Okay, the only difference here is you have a matrix at the top here for vectors is I, J, and K. In this case, because it's a 3 by 3 matrix, so the matrix will have a value of A, B, and C as in real values. So we just substitute the I, J, K with A, B, C instead. So the formula remains the same, the shortcut method again. So if you want to find anything associated with A, cross the row and column which is associated to A, and then we're going to get the determinant which consists of this 4 elements. So this is the determinant here, and we copy the A over here, and then next it is followed up by the second element which is B. So to get the coefficients of B, what you need to do here is you need to write a minus B here, okay, and then close the row and the column which is related to B, and you will get these two elements to be a part of the determinant. So this would be the determinant, the F, G, and I. Okay, next, in order to get the element of C, so C would be plus C. Okay, so close the row and the column which is associated to C, and these 4 elements would be your determinant or the coefficient of C. Right, so it's similar to the 3 by 3 vector product for A cross product for A cross B. Okay, it's a similar thing. It's just that ABC now is actually a value, not IJK. Next, we will look at how to determine the inverse of 2 by 2. The inverse of a 2 by 2 matrix can be identified as A to the power of -1. So this simply means inverse in matrices. Okay, so inverse of 2 by 2 is so this is the formula for it. So 1 over the determinant AD minus BC. Okay, provided the determinant cannot be a 0. If the determinant is a 0, then the matrix will not have its inverse. And you need to interchange A and D and multiply B and C with -1. And so this is the formula to determine the inverse of 2 by 2 matrix. Provided AD minus BC cannot be a 0. If it's a 0, then it will not be defined, or it will not have its inverse. And there is a term which is called by when you swap the AD and you add a -B and -C, is called an adjoint or adjugate of A, and it's denoted as ADJA. So in matrices, the terms are very important. So make sure you get all the terms right. Yeah. In conclusion, if AD minus BC is a 0, the inverse is undefined or don't exist, or it's not invertible, right? So if it's not invertible, the matrix is then called singular. So so there are few terms when AD minus BC is a 0. So the matrix is not invertible, the matrix inverse is undefined, or the matrix is known as a singular matrix. So it doesn't have an inverse. So there are a few terms which are related to the determinant. Make sure you know all the related terms. And if AD minus BC is not a 0, then the matrix is non-singular and is invertible. Next, for example, if you have A as given this matrix, all right, and you need to find the inverse. So applying the inverse formula, 1 over AD minus BC, so is 2 times 3, 6, minus 4 times 1. Okay, so you have a value at the denominator, so the inverse exists. Okay, and then you need to swap the 2 and 3, it's being swapped over here, and you multiply B and D with -1. So that's what we did over here, and you will arrive to your inverse. This is the inverse of the matrix A. And next, example, if you need to use matrix multiplication to solve this set of linear equations. So how to write this in augmented form, right? So we can write this in the equation form. So this is similar, 2, 3, 1, -1, xy, 1, 3. When you expand this, you will actually get back the 2 by 2 system of equation. So how to solve this? You need to find the inverse of this matrix and multiply it with 1, 3. So in this case, the inverse of 2, 3, 1, -1, this matrix is given here, 1 over AD minus BC. And then we swap the A and the C, and we add -1 to the B and the D, right, using the formula for inverse matrix. So after identifying the inverse, we need to multiply it with 1, 3. Okay, so this is the working. So you find the inverse of 2, 3, 1, -1, and then multiply by 1, 3. You should get your x and y, which is 2, -1, respectively. So this is the solution for this set of linear equations. Now we're going to identify the inverse of a 3 by 3 matrix. So to identify the inverse of a 3 by 3 matrix, you need to apply Gaussian elimination, where you can perform elementary row operation to solve AX equals to B. So A is a matrix, the B is a matrix. We need to solve the X. So for example, you can reduce AX to IX, and then IB to A inverse multiplied by B. Okay, so in this case, you can convert A to I, and you can also convert I to A inverse using these elementary row operations. So these are the 4 steps which are important to identify the inverse of a 3 by 3 matrix. Okay, so you need to place A and I side by side with A on the left and then perform elementary row operation to reduce it to I meaning identity matrix, yeah, of a 3 by 3 matrix, and perform the same elementary row operation on the identity matrix. When finished, I will represent A inverse. Okay, so I will show you the steps in the coming slide. For example, if you have a matrix A, so the first step is you need to write matrix A. Okay, we have copied down this matrix A side by side with I, the first step. Okay, next step here would be using elementary row operation to get a triangle of zeros at the corner of matrix A. So our next task here, we are going to convert matrix A to become I using elementary row operation. So this matrix A here will become I, right, by using elementary row operations. So what are elementary row operations? You need to get a triangle. So you need to convert A to I. As you can see, A to I has a two triangles of zeros here. Lower triangle here, and we have an upper triangle of zeros. So you need to work out your matrix so that you get upper and lower triangle of zeros. So you need to convert your A to an identity matrix. So now we will see the steps. So first thing, okay, the steps, I just want to remind you that the elementary row operation steps may vary depending on which row and column you choose. Okay, so for example, if you want to make the 5 a 0, so it will be easier to use row 1. So we're going to label this one as row 1. Okay, we refer this as row 1. This will be your row 2, and this will be your row 3. Okay, so you know your respective rows. Okay, so we will use these rules to actually eliminate the values of 5 and 2 over here. So we start off with our left hand corner here. Okay, so it will simply be row 3 minus 5 times row 1. So for example, it is 5 minus 5 times 5 minus 5 times 1. Alright, so it's row 3 is 5 minus 5 of row 1. Okay, once you confirm that you will get a 0 for this value of 5, the other values you should follow through the same operation that you did between row 3 and row 1. Okay, so for example, it's row 3, which is 2, okay, minus 5 times 1. So 2 minus 5 is negative 3. Okay, next 3 minus 5 times 1, 5. So 3 minus 5 is negative 2. So the next elements follows the same operation that managed to make the 5 a 0. Okay, your next step would be you want to 0 your 2. So again, we use row 1. It will be 2 minus 2 row 1. Okay, so it will be row 2 minus 2 of row 1. Okay, so in this case, you perform the operation row 2 minus 2 of row 1. Okay, and you manage to 0 this value 2, and the rest of the elements in row 2 will follow the same operation. So for example, it will be negative 3 minus 2 times 1, 2. So negative 3 minus 2 is negative 5. Okay, negative 1 minus 2 times 1. So negative 1 minus 2, it will be negative 3. Okay, just be reminded you need to follow the same operation for the rest of the elements in the same row. Okay, and then next, now you need to 0 this negative 3 because you need to convert A to I. So we have 0 the corners, first two corners. Now we need to 0 the element 2. So how are we going to 0 the element 2? Follow the same procedure. it will be to 0 the 2. What we did here was 5 of row 1, 5 of row 3 minus 3 of row 2. Okay, just be reminded, when you want to, after you have changed row 2 and row 3, okay, you need to, when you need to 0 this value 2, you should involve only row 2 and 3. This is because you don't want to manipulate the zeros here anymore. Okay, so for example, we took 5 of row 3, okay, minus 3 of row 2. Okay, and then you will 0 this value here. Okay, so you need to use this matrix. So it's 5 of row 3, which is, that's why we multiply negative 3 with 5. Take away negative 5, multiply by 3. So you will 0 the negative 3 here. Okay, so you've got the triangle, lower triangular for this matrix. Now you need to work on the upper triangle. So you need to 0, this triangle, so that it becomes a perfect inverse matrix. Yeah, so we need to 0 this triangle. Okay, so what we need to do here is, it will be 5 of row 1 plus with row 2. Okay, so 5 of row 1 plus with row 2. So it will be row 1 equals to 5 row 1 plus row 2. So you will get the first 0 here. The first 0 is achieved. Now you need to 0 the 2 and the negative 3. So you continue, next step, right? And then you continue the same operation till you actually get an upper triangular of zeros over here. Okay, right? So once you get in, you already got the two triangles of 0. Remember, you need to convert it to the I matrix. So you need to actually change your, you need to actually manipulate your 5, negative 5, and 1. So in order to get a perfect identity matrix, what you need to do here is, you need to convert the 5 and negative 5 to 1 and 1. So you can use division, right? So first row you divided by 5. The second row you divide by negative 5. Okay. And you will get a perfect identity matrix. So once you have got the identity matrix, the matrix which is on the right hand side will actually represent the inverse matrix. This is how you work out how to get a inverse matrix using the 3 by 3 system of equation reduced using the elementary row operations.